Welcome to the Construction Brothers Podcast. I'm your host, Tyler Campbell, and with me, like he is every week, my brother, Eddie Campbell.
What's up, Tyler?
Not much, Eddie. Well, this week we're talking 5 questions to ask before you prefab.
I had kind of a moment of introspect before we got on today.
What's that?
Well, I took the sleeve off of my unbranded coffee cup.
Oh.
Like, is this something I've gotten self-conscious? Like, are we supposed to worry about brands and such things on tables?
I don't know. This is just water. So
I feel
like
pretentious asking that question.
Yeah.
And it just struck me before we started that, like, I have a brand and I'm just, yeah.
I can assure you, Eddie, nobody cares.
The 5 people that are going to listen to this.
No, it's not even listening. It's just watching. Like just the 5 people on YouTube. Maybe.
That's true. Actually, if you go and look at our YouTube videos, you will find that is a fairly accurate metric for how many people are actually viewing the YouTube version of this.
Listen, guys, we're raking it in here. All right,
7 to 11 views. I'm going to say solid.
Let me just
week.
tell you, I'm going to start a course on how to run a YouTube channel. That is what I'm going to do next.
You need to, because it's blowing up. I mean, you figure every 3-4 more views is like, I mean, what's the percentage growth on that? It's got to be pretty big, right?
Yeah. Mr. Beast is, he's got a lot to learn.
Yeah, look out. Here we come.
Here we come. Well, Fu, nice to see you, man. How's everything going in your neck of the woods?
Hey, that's a great problem to have. Is branding your coffee table. I think that's good. Those are big city problems right there.
I'll tell you what.
Yeah. Probably a lot more high rolling than we really are. So,
heck yeah. Well, Fu, all right, dude. So we've talked before. Tell us who you are, what you do. I'm really pumped to dig into this with you because our last conversation was just killer. So dig in. Who are you? What do you do?
Sure. So my name is Fouad Khalil. I'm the principal at a consulting firm called Modly. Or I like to say I'm a reformed architect. I started out in architecture about, almost 25 years ago now. And then kind of really from school, but really in earnest, I'd say about 15 years ago, started really getting into offsite construction, modular prefab, and offsite, and then ended up helping to start and working at a company called Blocks, which is in the medical space and does a lot of that work, really all formats of what I would call industrialized construction. So construction under roof using manufacturing techniques and methods applied to the field in an integrated way. So working in the both design side, the manufacturing side and the construction side to deliver, either portions of projects or projects from whole cloth. And as my work in Modly, I've continued to work with owners, product owners, and buyers of IC in various capacities to kind of further that. I think it's just a really important issue for the industry right now. We've got productivity crisis, we have runaway escalation, we've got a lot of things we need to work on and solve, and IC is a good vehicle to do that.
So, dude, you said industrialized construction program. Can we open that up a little bit? Like, what do you mean by that? Dig into that a little bit deeper for me.
Yeah. So, I mean, one of the things that you are trying to do in industrialized construction is really attack aggregate productivity in construction, which I don't know if you guys have probably looked at this, but there's a lot of charts out there where you're looking at the improvement in productivity across the economy since, say, 1960. And then you see the improvement in productivity in manufacturing. And then you look at the improvement in productivity in construction. And what you'll see is construction's generally flat, maybe even declining a little bit. We could talk about reasons for that. And then where the economy is higher, significantly higher, and manufacturing is significantly higher still. So if you think about, and this is not a new topic, but if you look at the amount of car you could afford to buy in 1960 and what it had in it versus the car you can buy, in 2023 and what it has on it, so you're almost talking about like a spaceship compared to what you could buy in the 60s. It's getting harder to deliver that level of value or perceived value to construction customers. The buildings are getting more complex. The regulatory environment's more difficult and more granular. And everybody struggles with, the same things: quality, speed, and budget. And so I see programs are a way to handle that. And really, it's kind of a low-hanging fruit. You want to try and find areas where there's a lot of repetition, where you could develop some standards and really build a program around that so that you're not kind of losing your gains as you go. I mean, one of the problems we have is we'll put a team together. Of course, you guys probably talked about this a lot. We'll put a team together. They finally get good at it. And then we call it done and disband the team, and they never see each other again in some cases. And so we lose all of those gains. We don't know how to transmit that to kind of the next generation of project members. And I see programs are a way to kind of develop that continuity where it makes sense and start attacking this loss of productivity.
I'm going to press the dummy button here. IC. What is that acronym?
Yeah, industrialized construction.
Okay. Just making sure.
So I'll use that term rather than and that's got everything from lean, because obviously lean comes from Toyota Production System. So everything kind of from lean through, offsite is we're going to take something from the building, build it offsite. Prefab is we may productize that and create that under a plant, but in a more organized way. And then modular is, we're going to build it out of a set kind of kit of parts, and we're going to use that kit of parts interchangeably throughout. All those things would fall under IC.
Gotcha. So when we talked before, you had mentioned 5 questions that you go through and you ask yourself. You're deciding whether or not it's worth it to prefab, essentially, right? Is it a good candidate for prefab or this industrialized construction, right? So can you walk us through what are those 5 things, and then we'll kind of step back and we'll go into each one into more detail, I guess.
Sure. So the 5 kind of general things I'd look for is, 1, I call volume. So, volume is the answer to the question, is the juice worth the squeeze? So we're going to go through a lot of effort trying to productize and standardize something. Does it represent enough return for us is the deal big enough? Is the customer big enough? Is the use of this product or this IC method enough to justify the effort? So that's the volume question. The second thing is pipeline, is do I have enough of it spread over time? So if I'm going to just do it once and I'm going to do it for 18 months and never touch it again, that may not be enough time to actually work in the improvements that we need. So pipeline is that volume over time. The third one is repeatability. It's kind of basic. Is every other part of this thing unique? Am I doing an apartment building, but I have 50 different unit types, and I'm trying to, standardize that? That's going to be pretty hard. So I'm looking for a high degree of repeatability in the sort of product category. The fourth one is design. Do I have design on board? Because when we're kind of working through the improvements, we need to have pretty quick design iterations, and we need design to track through all of the improvements. Obviously, when we design something the first time, we'll do it, we'll get feedback. If design isn't on board, I don't have any way to roll that feedback back in to improve the product. So I need design there. And then finally, optimization. And that's really distinct from design in that optimization happens at the production level. So in manufacturing, you have engineering teams. They actually pick up from design, take it to the plant floor, and they're designing the production system. How many man hours, what is the man method machine that I need to actually create this product, and how do I improve margins on that over time? So that optimization layer has to be, really I'm looking to see, does that exist or can it exist as part of the program on an ongoing way? And if I have all 5 of those and that they're balanced with each other, then I have a pretty good candidate for an IC program.
You mentioned how, you learn how to do something, and then it's as soon as you get to that place where you learn how to do something, it's almost like the end of the project comes and you abandon it. And I'm talking to an erector the other day, and he basically said that. We get through this process. They had a job that was basically doing the same thing. It was pretty repeatable. And he said, I think we got it figured out by about the last one to where they like really had it just nailed and put in. So you're taking that volume and that's part of the equation here. So how big a deal is that? And then what's the economy of that as you spread that out over multiple projects?
Yeah, and that's one where I think it makes sense. I mean, the most obvious thing is like, are you a serial builder? Like, do you have a need to have a lot of facilities going into the market? Maybe you're spread out geographically. You may be a large healthcare company and you're trying to make sure that all your bathroom fans are the same, whether they're in Wyoming or Georgia, right? So like obviously there's a need for that. And there's a certain amount of, you're a large system, you got lots of hospitals, lots of ceiling fans. So that starts to make sense. And over time, you're going to refresh that fleet. You have global companies in the United States that have facilities all over the country and that want to make sure that, people's experiences are the same, whether they walk into one side of the country or the other. And they're looking at a multi-year build out. Like those are the clear and obvious candidates for a deal with enough volume there that it makes sense. So, I mean, I don't know if that answers your question, but I mean, intuitively, it's really the size of the construction spend in total and its kind of criticality for the enterprise, right? So we were just talking before the show about data centers. Data centers are a good example where you see a high volume of construction spend. Obviously, some standardization, industrialization is probably already happening there. You have healthcare is another big one. Housing's a little bit trickier because regional developers, they have certain fleets. Some are national, some are regional. They're looking at it, and it can be a little hard to evaluate in terms of housing. Are we big enough to really invest in an IC program? And that's where, I try to work with clients to try to evaluate that. But there's some cases that are very clear cut. I mean, you look at McDonald's, right? Obvious candidate. Obviously, they're doing probably their version of that IC. I know Chick-fil-A, another big company with a very progressive approach to construction. I know that's one where there's clearly a lot of volume. They're one of the fastest growing franchises in the country. So it'd be that kind of more on a business model. Does this make sense? Does this fit in with our business model? Are we the kind of builder that needs to look into this? Does that answer your question?
Sure. Yeah.
Yeah. So, I mean, it's more of like owner level question, right? Like, is this enough
Definitely.
for us? Okay. So move down into pipeline. What is that? Kind of unpack that a little bit more for us.
Sure. And so with pipeline, one of the things that you're always kind of running into is plant capacity. So let's just say the first answer is yes. The second answer is, all right, we need to find a facility. Maybe we need to build our own plant, right? So think about it from a plant operator standpoint. I have this factory, it can do certain stuff, or I have a very large shop, and we can certainly build a lot of units there. The question I have is, do I want a really big job that comes in once, say over 9 months? I have to ramp up capacity huge, and then these people go away and I never see them again. Or would I rather take that same amount of volume and spread it out over 3 or 4 or 5 years, where I can set up a production system, I can level out my line, I can have consistent staffing, I can have consistent flow, and I can do a much better job of forecasting my business over time. Any plant operator will tell you that's a layup question. Of course, you're going to want that over time because you really want just a consistent flow of production rather than extreme, high levels, and then you got to let everybody go and then you got to rehire them again. So that the way you take that volume over time is what I consider pipeline. And for that, you really do need it to be kind of consistent and over some period of time, over some years, ideally. That allows you to kind of do some of the other things that you need to do much easier. Does that make sense?
Yeah, that makes a lot of sense. It's how much the plant can handle, right? Like how much our manufacturing facilities can actually deploy to the field, right?
Yeah. I mean, you'd be really surprised how much some of the constraint is. Like, we'll get owners come in and they'll say, yeah, hey, guess what? We're going to need, this many buildings built modular, and I need them all delivered at exactly the same time. We're going to just boom, they're just going to show up. And that really doesn't work from a capacity or operation standpoint. And as you hit the upper end of your line capacity, you can only produce what's sane. Most plants like to run at 80% efficiency. And we're kind of used to sprints. We're used to like, hey, let's flood the zone and get this job done and get everybody home. And manufacturing doesn't work like that.
All right. So the next one is repeatability, right? Dig into that for us.
Yeah. So, there's a lot of conversation these days about automation on one hand, and being able to like roboticize certain parts of construction. That's on the one hand. And on the other hand, there's a lot of conversation about mass customization. Hey, we'll just feed you the code and the widget comes out beautiful on the other side and it's all like ones and zeros. And in reality, if you're really going to produce something at a reasonable cost, most of the time you do need high levels of repeatability. There are still a set of hands that have to learn how to make this. And in fact, back to the hands, these are the hardest things to automate. These fingers of ours that are so great at hammering and twisting and taking this stuff off. Those are the last things those are very complicated operations to automate. So both in terms of just the simplicity of developing a program from a design standpoint, where you're not having to run so many options that you may or may not need, and just the unit economics, you need a high level of repeatability. And that'll vary depending on the size of the component. And a building, maybe you can repeat, if it's big enough, you're doing it 8 times, right? But a bathroom, you may need to do 150 times before it's profitable. But you will need a high degree of repeatability. I would caution people in thinking that you can automate that away or you can mass customize that away. We're still at the infancy of this thing, and repeatability is a key element.
All right. So next up is design. Dig into that a little bit more. Like, what is that?
In general, in construction, we've probably all grown up in the over-the-wall kind of method where, hey, Mr. Architect needs you to get done. All right, get it to me for pricing, get the feedback, finish up the design, and I need you to draw it, to the screw. Then I know exactly what I'll need to do. I'll take it from you. Thank you very much, and I'll build it, right? One of the things I started learning about when I started getting into this was a Toyota concept called simultaneous design or simultaneous engineering, which is really a way to integrate the production side of a manufacturing operation and the design side, so that as you're designing the product, the engineers are working on the production system and they're feeding back, hey, is that part you guys are doing, is that actually buildable? And why wait to find out that we got to make this adjustment after the design is finished? We need to know right now, how do we develop the production system? How are we actually going to build this out? So I need my guys that are on the floor, my foreman for the guys that are on the floor, my master tradesman, or whoever's the SME is for, say, my electrical or mechanical or welding or whatever, working in that big room with my designers. And as the design iterates, I want to be able to run those iterative cycles with that whole team as quickly as I can. And the more iterative cycles we can do together, the better that build out's going to be. So design really has to be on board the whole time, for the whole life cycle of that product. And you need to have continuity there. They need to be responsive. They need to be accountable. If we're having to stop production because of a design flaw, the design team needs to be committed in resolving that in real time. So I'll just give you an example on that. I had the privilege of working on the Walmart Health Program, which was a really ambitious build out we did with blocks. And, our team's day started at 7 a.m. manufacturing stand up on the plant floor, because we didn't want to wait to hear about what was holding up our production team for our 8:30 design stand up. And so we had a stand up meeting at 7 a.m. with the manufacturing folks. We did our own internal 8:30 stand up. We kind of absorbed whatever they needed, triaged the issues. And then we had a 3 p.m. afternoon stand up to make sure that whatever we identified in the morning was going out by the end of the day. And that's how fast those iterative cycles can be. They can literally be a matter of hours. And when we worked with our colleagues from manufacturing, what was really impressive to me was that's the pace that they run those plants. When you're trying to get a car to market and you're doing the first build out, you've heard the horror stories about Elon Musk having to sleep at Tesla. That's because the pace is so relentless. Once you get things going and working, your margins get pretty good. Tesla's doing pretty well now, right? You hear about them kind of beating expectations, but that initial setup was a nightmare. And that's what it's like getting these products launched. It's very, very tough. So design has to be an integral part of that, or it just doesn't work.
I feel like so often we think through design from just the standpoint of the architect or the engineer and not just the system that puts everything together as well.
Right.
And yeah, definitely heard of like, hey, there's time and investment in building out the systems and processes to make this a possibility.
Absolutely. Ideally, those things are tightly coupled. The manufacturing system informs the design, and the design informs the manufacturing system. Sometimes you have to change the design so that it's more buildable. Sometimes you have to change the setup on the floor because the design demands it. And it's like, hey, we got to strip down that line and basically rebuild it so we can build this new product. Both of those have to be, like I said, tightly coupled. They got to work hand in hand.
I mean, that falls right into our last one, which is optimization, right? So dig into that a little bit more. How does that fit in?
Well, that's the flip side of that coin to me. So what I call optimization, I would characterize that as engineering and production optimization. So, hey, we've got everything working, but what we really want to see over the lifetime of this program is we want to see those unit costs get down, okay? And the only way to do that is to attack it on the manufacturing, on the production side. And that's what manufacturing engineers, process engineering, line staff, Kaizen, all of that is about, that optimization in manufacturing. And ideally, you're doing that in the field as well, right? So the field is just an extension of that operation on site. But without that optimization, that optimization is what allows us to buy a car that can basically drive itself in 2023, from where we started. And you have to assume every product that gets prototyped in the beginning is going to be too expensive. It's going to be like, man, how are we going to get this to work? This is so hard. Like, they want this for this number. We're doing everything we can. The materials cost this, the labor doesn't, we can't get our guys trained. It's really difficult. But then over time, by the end, the miracle of manufacturing is that you can attack these problems and you can solve them. And there are tools to do that. So that optimization layer is key. And really, the more we can socialize that and extend it through our colleagues on site, that multiplies it even better, right? So you want the guys on site to come back to you and say, you know what? We tried marrying these two modules together and I could not get to 2 out of the 3 connection points. You got to do something. And that's part of that as well. You know what I mean?
I do think of Tesla when it comes to optimization. It's funny how, in the early days, the adoptions of EV and having Tesla become a thing. I remember like the first time I saw a Tesla store. It's in the luxury mall.
Yeah.
Right? Very few of them on the road. You don't see it much. There's this impediment of like being able to charge the things. Where do I charge it? Where do I charge it? There aren't enough charge stations. We're still trying to solve.
We're still trying to figure that one out.
Right. But as we lean in, as it becomes more commonplace, and as it's expected, people adapt behavior in order to adjust life to live that way, right? Design's got to do kind of the same thing. Construction's got to do the same thing. Like that optimization's not going to get a place to happen until we start implementing it more and more. So I think it's worthwhile to talk a little bit about like the kind of the impediments to entry, because these 5 points, we could also go back and say, if you're not examining these 5 points, if you're just kind of throwing modular into a spec and saying, we're going to do this, that you haven't really planned anything that's going to work out all that well. And that's been my encounter is, hey, this is a modular site. Why don't you
end up taking longer?
Why don't you figure out that module there? guys.
Yeah. I mean, modular is like a field goal, right? It's like you throw it in the spec and it's like, I don't know, let's try modular, and at that point it's usually too late. You're bringing it in late as an option or an alternate add. Everybody kind of wants it. Everybody thinks it's cool. Nobody really knows whether it's going to work. And guess what? 9 times out of 10, the numbers come back and you're like, oh yeah, we tried that. We can't afford it. It's crazy. Well, that's really because it's too late. And again, we think about the importance of designing around a modular delivery system from the get-go. And when the design's already completed and contractors are trying to see if it works, and your mechanical, electrical, plumbing sub have already submitted their numbers and you're asking them to give you credit, it's going to be very, very hard to get that. I'm sure it happens, but you're sort of fighting against these 5 things instead of working with them. So it does take a commitment from the owner. Again, is the juice worth the squeeze for the owner's organization? Is there more than just a single job where you want modular? I think a lot of the times people assume that this is just a product that you can buy off the shelf. And that's really not the case at all. We're used to much more of a tailored fit for our construction customers in this country, and that's a good thing. I don't think we should step away from that. Facilities have standards, they have needs, they have lessons learned they want to incorporate into the product, and I think they deserve to have a product that works for them. So it does require some strategy and some planning if you really want to implement modular, in my opinion, the right way. That being said, I hope there are products that come to market that you can pretty much buy off the shelf. I wouldn't be against that at all, but you're either going to over-design that product where it's like a Swiss Army knife of a thing and it doesn't really work for any one thing very well, or you're going to under-design it. You're going to want things in it that it doesn't have because your facility needs something. So to me, the owner is the best place to start.
It's funny, we relate back to steel so much, but I might look at a design that an analytical model was run on and beams are optimized, right? Air quotes optimized. So you get the optimal section size for the build, which means the section sizes could be absolutely and utterly all over the map, but they are optimized for the exact span that they're going to. There is economy to saying, yeah, I know, 1219 would have worked there, but I'm going to go 1222 because it happened 10 more times across the bay, and we're going to buy a lot of 1222. So this is where I want to talk about, maybe we can productize a little more. Maybe that is over-designed, but is there a use case for saying, well, we're going to accept the air quotes over-design because the economy is actually coming out and the ability to repeat?
That is a fantastic point. I really think we need to unpack. We could spend a whole session on just this. So we're really used to a siloed kind of construction model, right? You've got your structural engineer. He's kind of working in a vacuum. He's sort of talking to the architect and sort of kind of like you said, optimizing for load, right? Optimizing for the weight of the steel and what's available. Is he optimizing for the speed of the build out? Probably not, right? Is he optimizing for what the crew needs to actually install easier? Probably not. Is he optimizing for repeatability or sort of modularity where, you know what, if we make everything out of 4x4 tube steel, it'll be a lot easier to deal with this design than having 6 different sections. And actually that was a big part of our process at Blocks. I think you have to broaden the definition of what you're optimizing for and include all of these other considerations in quote unquote optimization. Because if you don't do that, and if that's not led by a very competent team leader, you get the silos optimized for themselves at the expense of everybody else. And they have no way of knowing, this is how we talk about, kind of feedback and optimization. They have no way of knowing what the build team needs until it's too late, until they get the feedback back from the site and they say, hey, man, it's cool. I'm glad we used that section for the load, but I can't get this thing installed, or it's taking us 3 times as long, or I can't find it, or it was delayed. So that process I was describing, more of simultaneous engineering or simultaneous design, that allows for all the parties to see, hey, what are you thinking about that? And have you considered this or have you considered that? And sometimes you overrule one of the silos so that it's a better fit with the entire thing. The integration aspect of that is often underappreciated and very important in IC. You have to integrate all these things together at once from the get-go.
The demonstrated economy of something like that will eventually, I believe, drive the cost down, because, I can say all day long to a steel fabricator, well, I know it weighs a little more, but you've got this economy sitting here. But if the only metric they have to take it off is a weight metric, they can't get it out of their head. Their bid is going to be higher, even if they are working less. And you have to demonstrate economy and or make it their idea. They had the idea.
They love that.
Yeah.
They do love that.
And then that demonstrable economy that you've said, okay, no, we've done it one time. How'd it work? Everyone worked well. Okay, how are we going to tweak? Like this. All right, let's go back. We're going to drop the number a little, right? We're going to drop the schedule a little. All right, again, until we get it down. But I don't know that we're getting that repeatability enough quite yet in the industry to demonstrate it.
Well, at the risk of speaking for them, I think the world of these guys. My old employer, Blocks, we spent a lot of thinking like that around the modular frames that they use to build the buildings with. And if you think about it from their standpoint, they're looking at the mill runs. So when can they get product? When is it being run by the mills? Okay, they're trying to keep their inventory to an absolute minimum. They're trying to have that order be simple. So the fewer number of unique sections, and they use surprisingly very few, their frames are like tanks. But part of that is a strength issue. Part of that is a weight issue, because they don't want the building to feel hollow. They want it, it has to resist lateral forces on the coast. It has to resist seismic when you're out west. And it's the same frame, right? So all of that has to get factored in. You're talking about when you can get product from the mill all the way to installing it in the field, and what do the installers need? And we had some of the best steel guys. They have some of the best steel guys, I think, out there. They call them Steel Team 6 because they're so good.
That's epic.
I mean, you're talking, they really are, and so their feedback is essential. They take that feedback and they pour it into the next design as soon as they can. As soon as they can catch it, it's put in and it goes through the line. So that's the kind of optimization we can start to achieve in IC. And the reason why you can do that is because you are going to repeat these projects. And so it's kind of like thinking about the iPhone, the way Apple kind of they'll release whatever, the iPhone 10, but they know the feature set going in all the way out to the 14, maybe the 15 or the 16, right? They're just working on, releasing each release in a controlled way so you get your next set of features. It's exactly that. When you have a long-term run on a product, you can start organizing, rolling in these advanced features, and ideally lowering the cost, the complexity over time.
Kind of going back to the engineering side of this conversation, and something that you said spurred this on was we're designing in a silo, like you had said, Fu, and there's no incentive for our designers in kind of like a current standard way of building to optimize. What are they getting out of that? Absolutely nothing. Mm-hmm. The best thing that they can do is build it so that it doesn't fall down and cover their butts. Fair. That's fine. I think that's a fine sort of way of looking at things, but that's the only thing that they're looking at. They're not getting paid to optimize it too. So I think we're kind of in this little stalemate almost. Is like we need it to be optimized for the field, but we're not paying for that optimization to happen. So everybody's just kind of pointing at each other, right?
Yes, that is another excellent point. And I think That's kind of why I feel so committed to IC right now, because it's almost like the space program that we need in construction. Because you're right, nobody is incentivized to get, everybody just wants their project, gets in there, gets on time, on schedule, wins the design awards. It's awesome. Everybody gets like a cookie at the end. But these things that you're describing, they only happen through repetition and iteration and optimization, and we don't have a venue for that. And so we need these IC programs, not just because they benefit the owners, the people who are buying them, but because through them, we'll be able to develop like the next generation of techniques where we can port that out to the one-offs, right? To the also building owners who don't have these huge build-out budgets. All of that stuff will make its way back to the industry and help productivity overall, the little guy and the big guy. So that's one reason I'm really passionate about this. There's a lot of stuff I could be doing. I think this is the most important thing I could be doing right now to contribute to the industry and make it better. Because eventually, we learn through copying, we learn through dissemination of best practices in construction. And this is a really good vehicle to achieve that.
I can't help but think about F1. Not going to lie. Like, this is always where my brain goes, is back to Formula One. Hey, sorry. Go Red Bull. Let's get it. But you look at the cars that they're producing in F1 and it's just like, it is top of the line, right? That they are putting so much effort into each and every single one of those cars. But that car is also influencing like the consumer side of things, right? And the consumer side of things is also influencing F1 in some capacities too. So it's like, I feel like in a lot of ways with construction, like we need more of that. We need more F1 teams out there. They're just like cutting edge, just investing like crazy in this stuff. I don't know. What do you think, Fu?
Well, are you bringing up F1 because it's such a kind of a high spec environment where
so I think it's kind of symbiotic, right? So like you have this team, like this team that's out there that's building this high performance thing. And it's kind of a one-off, like they're investing a ton of money into making one thing really freaking good. And then you have the same sort of company that's building these repeated modules over and over and over and over and over again, right? And they're both learning from each other. Like there's room for both of those things.
What's like a company example of that? What do you mean? Like a consumer side product that's going back into F1?
Aston Martin. We'll use them as an easy one. Like their racing is going to influence the consumer vehicles.
Yeah.
And the consumer vehicles are going to influence the racing.
Honda's a big engine maker, right? And they have
Honda would be a good example, I guess. We could use Red Bull.
Yeah.
Red Bull would be a good example of that. But they're actually getting ready to move to Ford. They're going to be using Cosworths.
Oh, well, there you go. But what is it to run one of those teams? It's like 150 million a year,
200 million a year. That's the cap. That's the team cap that they put on it.
Wow.
Recently.
Yeah.
So I don't know if that point tracks in the conversation. It was based off of something that you had said earlier of like, the one-offs benefit from the repeats, right? We're still learning from that. Like the space race, we benefited a lot from that, from these big, hairy, audacious goals. We have ballpoint pins because of the space race, right? Little things like that, which get me going on space.
I've thought about this a lot over the last few years. My experience at Blocks was in some ways, that company and other companies like that we just don't do R&D in the construction industry anymore. We really don't. And people say they do, and they'll have a drone program or something like that. And it'll be on the website. It's like 5 guys, 3 interns, or some young guys. Yeah, we got the drones, and can we get that on our job? Well, no, that's we're not going to put that. You hear that there's all of that stuff, but you really do need a serious R&D function in the industry. Obviously, Formula One is a venue for that, for automotive, and $200 million a pop per team. Clearly, they're that's real money.
serious money into it.
And I always got the sense while I was at Blocks that we were actually the construction version of that in a lot of ways. And we really do need as much of that as we can get. It has to make some sense. I don't think it has to pencil out completely every time, because the value of the research has its own value. And anything we can do to promote that, where it's a real life exercise, just like at the track. One of the other problems with R&D, the way we think about it is, well, it's an academic paper. Well, that may or may not get instantiated in the field. And without that field feedback, you're only doing half the work. So IC programs give you real-time feedback on whether this is working. And I think do a lot of the same function as a Formula One would in automotive.
Yeah.
And we don't have that anywhere else.
All right, Fu, it's time to ask you our favorite question. All right. So if we gave you a megaphone and around 60 seconds to speak to the whole construction industry, what would you want to say? What would you want to leave with?
I would just strongly urge trying to educate owners on the need and the cost of setting up a recurring IC program. If you're going to be interested in really doing modular, talk to your VP of construction, talk to your business owner, and really have a hard conversation about, are we up for this? Because it is as demanding on the owner's organization as it is on the construction team and the fabrication partner. And so without that kind of commitment, it's not really going to work. The owner is as part of the deal as anyone else, and without their backup and commitment. And we lived and died by our owners. When I was in production, working on those projects and those products, were it not for our owners, we wouldn't have a leg to stand on. And often they were the ones that, when it came down to the wire, they made all the difference. So it really is a partnership. It is definitely worth doing, but it requires everybody to kind of pull together and work really, really hard. It is really difficult to do, but it's very rewarding.
Heck yeah, man. That's a good reminder. That's a good reminder. Full commit, guys. Full commit. Send it. If you're going to do it, do it. All right, Fu. Thanks for joining us this week, man.
Hey, I appreciate it. Thanks so much for having me.